Hi, this is Brendan, and this video is to introduce you to the arithmetic series equation. Now, in a previous video, I discussed sequences, and so I want to just very quickly talk about the difference between a sequence and a series. Now, a sequence is simply a listing of the values. So if I look down here at problem 1, I'm just listing the values. I'm saying that 3 is my first term, 7 is my second term, 11 is my third term, 15, so on and so forth. Now, what a series equation is going to do is it's going to sum all the values. So rather than just having the values listed, we're going to be adding them. And so I want to just note that whereas this represents the sequence, what I have drawn here, this would be the sequence, the series for the same set of numbers would be 3 plus 7 plus 11 plus 15 plus 19 plus 23. Same thing for problem 2 over here. The series would be 9 plus 1 plus negative 7 plus negative 15. And this dot 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 means you actually keep adding the numbers forever. And we'll come back to why that's important in a little bit. So the idea of an arithmetic series equation that I really want to kind of drill into everyone is this little epsilon symbol, this summation sign. It looks pretty intimidating, but it's not as bad as it appears once you know what it means. It's really not too bad. All this means is that for each value of n, you take the value of that term and you add it. So let's kind of show how I can write this equation down here as this. So my first term is 3, my second term is 7, third's 11, 15, 19, 23. So what I can see is that I have 6 terms. Now, n equals 1 is going to be my first term. There is a way to write this as n equals 0. We're not going to do that here. And I'm going to put 6 up here because this number at the top needs to represent how many terms I actually have. Since I have 1, 2, 3, 4, 5, 6 terms, I'm going to put a 6 up top here. Now, as far as what I'm going to put in this position, a sub n is equal to a sub 1 plus d times n minus 1. In another video, we showed how for this problem we can figure out what that is, so I'm just going to do that up here. So a sub n is going to equal 3 plus 4 times n minus 1. Distributing the 4, I would get 3 plus 4n minus 4, and combining like terms, I would get 4n minus 1. So I want to put right here 4n minus 1. And that's actually it. That's the arithmetic series equation. Now, to go from the arithmetic series equation that we have down here to this addition, let's see what we would do. So n equals 1 is telling us that the first value we plug in for n is 1. 4 times 1 is 4, minus 1 is 3. So my first term here is going to be 3. Now we count up in integer multiples, so after we let n equal 1, we then let n equal 2. So when I put 2 into this equation, I get 4 times 2, 8, minus 1, 7. And so my second term is going to be 7. Put my third value in for n. I've done 1, I've done 2. We're just counting. Next is 3. 4 times 3 is 12, minus 1 is 11. We can very quickly start to see how this series list is looking a lot like the one above it. Now I need to go to the 6th term without boring you with the tedious math. My 4th term is 15. My 5th term is 19, and my 6th term is 23. And in order to add these up, 3 plus 7 is 10, 21, 36, 55, 78. So the sum of that series would be 78. I'm just going to double check the math. 10, 21, 36, 55, 78. And that's how we can see what our summation formula is for a series. So we showed 2 different things in this video. We showed one, how you can go from the list of numbers or the sequence to writing it as a series by putting addition. We then showed how to go from the series written out to the formal equation for a series, and then we showed how you can go back from the series to just adding up all the numbers to figure out what the actual value is. Hope this video was helpful. Go ahead and try problem 2 on your own, see if you're able to figure it out. It's going to follow exactly the same steps as the one we just did here. Good luck.